Hi, so this is the FSM for my final project. So basically what I have here is I'm inputting the 4-bit data from the buttons that we're getting. So this is the output of the AND gate essentially. And the same output we're getting, which is being given to us by the elevator, is the 4-bit output. And along with these, we also have the priority flags for each, which are feeding into the multiplexer. So these 4-bit data is fed into multiplexer, and then it's fed into this register. So because our priority flag is active low, when the priority flag is 0, the data is sent to the register and it's stored there. This is the part of the FSM where we have two registers. So this is the current state, and then this is the next state. So we have S1 and we have S0. And that's feeding into the logic of the FSM, which is generated using the state transition diagram and the state transition table, truth table. And then the output, which is the current state, feeds into the final decision. So whether it's going to go up, down, or stay idle, which state it's in. So we expect up if the requested floor is greater than the current floor, idle if they're equal, and down if the requested floor is less than the current floor. So let's go through an example of each. So let's say that I want to go to floor 3. So now we're saying that the button side request is greater than the elevator side. So what we should expect is that the output of the comparator is that R is greater than C. So let's check this out. So we're getting that R is greater than C. So in this case, the output of the FSM should be that we are going up. And that's what we see here. So idle and down are 0, up is 1. Now let's say that we are, the elevator side is equal to the button side. So in this case, we should get R is equal to C because both of the current floor and the request floor are equal. So let's check this out. So we get R is equal to C. And the output that we should get for the FSM should be that we have up is 0, idle is 1, and down is 0. So we're just going to stay in that idle state. Now let's say the button side, we want to request a floor that's greater, or actually, let's request a floor that's less than what the current floor is. So now we have one that's less than, so we should see this part light up. Let's try this. So we say R is less than C. And if we look at the output, we see that up is 0, idle is 0, and down is down is high. So this means that the elevator will go down. So these are the 3 different scenarios in which we would be getting outputs from this. And this is what feeds directly into the elevator interface in order to allow the motors to be activated to go up, stay idle, or go down.